Good morning, friends. Today's topic is the oxochromes. We all aware with these terms oxochrome and the chromophores. In the last lecture, we have studied the chromophores in details, and I have given the idea about the which groups are called as the chromophores and which groups are called as the oxochromes. Now, in today's topics, we are on the focusing the oxochromes. So generally, the groups which do not have the unsaturations and the group that having the capacity to involve the lone pair of electrons and to increase the resonance of the systems, that all groups are falling the group oxochromes. Oxochromes are the which cell does not absorb the UV radiations, but if it is present in any compounds, then it brights the that compounds and shift the absorption of particular wavelength into the range of longer wavelengths. So these groups are attached to any groups or attached to any compounds. This helpful this groups helpful to improve its absorptions and increase the longer wavelength. We are considering the groups. The groups are the OH groups. If it is attached to any compounds, it increases its resonance. How it is increases its resonance, we can understand by structure also. If either structures of any compounds, if there is any chromophore, here O is the chromophoric groups we have studied yesterday in the last lectures, and another group is the oxochromic groups, OH groups. This is the compounds. When there is a presence of an oxochromic groups and a chromophoric group, what changes occur in that structure? This is our today's part of the study. So this OH groups having the lone pair of electrons, because oxygen is the having the valency of the 6 atoms in the valence shells. 2 electrons are involved in the formation of bonds. It is the divalent, valency is divalent. 1 electron is involved in the formation of bond with the benzene ring, and 1 electron involved in the formation of bond with the formation of covalent bond with the hydrogens. In the valence shell, total number of electrons are the 6. 2 involved in the formation of covalent bonds. 4 electrons remains on the oxygen atoms. So these are the 4 electrons. So these 4 electrons are in the form of lone pair of electrons. So oxygen having the lone pair of electron. This lone pair of electrons are the loosely held bond pair of electron or non-usable bond pair of non-usable pair of the electrons. So these electrons can involve in the resonance like this, form the new covalent bonds. At this formation of covalent bond, there is a formation of various types of resonating structures, means conjugation is there. There is a formation of conjugations. As the conjugation increases, means this bond shift here, means form the new bonds, means this bond break, and this breaking bond shift here, new bond formations. New bond formed, this bond breaking start this shift here means new bond forms, old bond break. This bond forms means one bond break. In this way we get the different resonating structures. So this resonating structure means the delocalization of electrons increases in these rings. As these groups are increases means the oxochromic groups and chromophoric groups are attached to the compounds, then they increases the resonating structures. As this resonating structure increases means the as earlier it is absorbing the wavelength of particular wavelength, but as it's attached with the oxochrome and the chromophore, the absorption of particular wavelength is increases and it becomes longer. As it becomes longer means it is increases the UV radiations at the higher means it's sharpen the or increase the intensity of the that particular compounds. So it is generally happen in the dyes also. This is all about the OH groups. Same way there is another groups is also act. Another benzene ring is NH2 groups attached. NH2 group is the oxochrome. Oxochrome is the NO2 chromophore. So NH2 is also having the valence 5 electrons in valence shells. 3 electrons are involved in the formation of covalent bond, sharing of electrons with the hydrogen atom. One is the benzene rings and form the covalent bonds. 2 electrons are remains as it is. These 2 electrons are in the form of lone pair of electrons on the nitrogen atoms. These lone pair of electrons are the unused non-shared pair of electrons. This electron can involve in the resonance, involved in the delocalizations, bond shifting takes place, and this again gives the resonating structures. Means here is also delocalization takes place and it absorbs the UV radiation at longer wavelengths. Means it intensify that particular compounds radiations. So this is all about the oxochromes and chromophores. Again group is the group is the OR group. OR also having the 2 lone pair of electrons. Next is the NHCS3 nitrogen also having the 1 lone pair of electrons involved for the resonance structures. Again new is the chlorine having the 3 lone pair of electrons for resonance. Again next structure is the CS3 can involve the 1 bond pair to form the CS2 is having CS2 does not having the lone pair of electron but it become the CS2 after involvement of the 1 bond pair of electrons. Another is the CO, another is the SO3H, etc. These are the oxochromic groups. So oxochrome is the mainly only group which self does not absorb the UV radiations but whose presence in the compounds bring about the shift of the absorptions is to longer wavelengths, that is OH, NS2, OR, NSCS3, Cl, CS3, CO, SO3H, etc. So this is all about the examples of the oxochromes and the chromophores. These two terms are more important. These two terms are very helpful for the understanding the various concepts. Once again I repeat the chromophore theory. This is one of the theories, chromophore theory. This is one of the theories to explain the color in the relation to structures. The color of the compound is caused due to the presence of the unsaturated group called as chromophores. Chroma means the color and force means the bearer. Similarly, there are the saturated groups called as oxochromes. Oxo means augmented and chroma means colors. These groups does not themselves cause the color, but they help to intensify the colors. Examples are the N double bond N linkage, and the name is the nitro groups azo. Next one is the C double bond S CS3 thio groups azomethanes. N double bond O nitroso groups carbonyl ethenyl. These groups may be acidic or the basic groups. It depends upon the conditions to which it is attached. So this group may be acidic or the basic groups, and they also help to improve the dye fiber affinity. Thus a compound is colored if the chromophore and oxochromes are conjugated to each other. Thus a compound is colored if the chromophore and oxochromes are attached to each other. Means the as we study this structure of benzene attached with the chromophore and oxochromes, means that gives the colors. Color means it absorbs the absorption wavelength to the higher wavelength, and that higher wavelength is fall in the region of UV, means colored regions, and it will impart the color to the solutions. So it is thus the compound is colored if the chromophore and oxochromes are conjugated to each other. We have shown you the how the conjugations are takes place. I have given the examples of the OH groups and NO2 groups, NH2 groups and NO2 group attached to the benzene ring, and you found how there is a conjugation takes place, and this conjugation how it is useful for the higher colors of the compounds. Many times there is a precursor to the dye which can be reversibly oxidized into dye. Dye can also be reduced back to this colors compound called as leucobase. So we have studied the leucobase also. If it is colorless, there is leucobase. Examples is the hydrobenzenes. Hydrobase is a leucobase. It is a non-colored. Azobenzenes formation. Azobenzenes having the colored compounds. So this is all about the new structures and how it is apart the color of the compounds. All the things we have explained detail and of the oxochromes and chromophore. I hope that you all understand this concept clearly, because this is the most important concept. It will helpful to our the organic chemistry also. So in the next lecture we will discuss the bathochromic shifts, hypsochromic shift, and another one shift is there. Two shifts are the bathochromic shift, hypsochromic shift, hypochromic shift, but there are two types of chromic shift are there. We will discuss in the next lecture. Thank you very much.